Subscribe to my channel.
Welcome to NextGen Telecom. Today's topic is carrier aggregation, and today's agenda is why carrier aggregation is needed, and configuration and signaling, SCell activation, deactivation procedure, and last is dual tag. In this session, we will break down carrier aggregation from configuration to activation so that you understand not just what CA but how it works in real network. So carrier aggregation allow a UE to transmit and receive data simultaneously on multiple component carriers to increase bandwidth and throughput. So let's start. Carrier aggregation in 5G NR is a multi-carrier transmission mechanism defined in 3GPP specification where multiple NR component carrier are aggregated at MAC layer under a single serving cell group. One carrier acts as a P-cell, providing control plane anchoring, while additional S-cell provide user plane capacity expansion. CA improve spectral efficiency, peak data rate, network capacity by enabling simultaneous scheduling across multiple frequency resources. The UE initially connect to the network using P-cell during RRC setup procedure. After connection, the G node will configure measurement through RRC reconfiguration by providing miss object NR report config miss ID. After that, this parameter instruct UE to perform measurement on configured carrier frequencies. Evaluate predefined measurement events such as event A1 and apply the associated threshold and reporting criteria as defined by RRC signaling. After that, if the configured measurement condition is satisfied, now the UE send measurement report, and based on that report, the G node B may decide to add an SCell. After that, SCell is configured through SCell to add mode list in another RRC configuration message. This configuration explicitly defines that SCell belongs to same P-cell as a part of the same carrier aggregation group. Here is measurement reporting itself does not establish any P-cell SCell relationship. UE does not assume this association it's on. The relationship is always explicitly configured by the G node B via RRC signaling because it's previously defined in the G node B. So you can see here the flow of CA, how the flow is. UE configure the measurement event. So event A1, UE monitor P-cell signal, and when P-cell quality across threshold, then A1 is triggered. Even A1 event is telling serving cell becomes better than threshold. So UE send measurement report. G node B decide to add SCell. SCell configured through RRC message, RRC connection reconfiguration. So RRC reconfiguration, you can see here SCell add mode list parameter is here. So through this secondary cell will be add. Later, it activated via DL MAC-C. So through the use of LCID to identify SCell activation and deactivation. So it's a switch on and off. A data transmission is done by this MAC-C. Measurement configurations explanation is here. So first G node B send RRC reconfiguration to UE, including misconfig in this configuration, misobject coding configuration, and measurement mapping ID. So after that, UE take action, start measuring based on configuration. It's monitoring SSB, RSRP, or assigner. So if it's monitoring on based on SSB, RSRP. So UE send measurement report to G node B and trigger when event condition is met. Next, event A1. So some discussion about event A1 and how it will be treated. So can network wants to add SL, it need a proof that UE is not about to collapse under a bad radio condition. That's where a A1 measurement event comes in. So A1 event entering condition is measurement minus hysteresis is a greater than threshold. Second leaving condition is measurement plus hysteresis less than threshold. Here hysteresis is some amount of offset value which is add in measurement actual measurement report, and if it is less than threshold, whatever threshold they decide, suppose that decide at minus 35 and it's less than minus 35, then so it is a leaving condition. If become it's minus 87 or that, so it will be a leaving condition. So measurement is expressed in a dBm in case of RSRB. If measurement consider is signer, so it's considered in dB. So hysteresis expressed in dB here. A1 event NCA ensure that serving cell quality is above a threshold before network add or active an SCell. Depending on what the network configured, it's through RRCRP signer. Is the P cell stable and strong enough? Because P cell is anchor. If P cell is weak, adding SCell is pointless. Radio condition is stable, so it's a safe to active or add a SCell. So unnecessary C activation in poor signal to avoid this if P cell in the poor radio condition. So how the in logs SL addition? So you can see here SPCell config in this SL to add mode list, and SL config here, SL config index 3. Okay, so here is the frequency, is the frequency band indicator. So why SL index is 3 means in next slide explained. Yes, now how SL will activate and deactivate. So MAC-C the element, MAC control element, as you know, the physical layer includes a control information such as UCI, DCI. Similarly, MAC layer also has its own control information known as MAC control element. MAC-C, these MAC-C are created by UE MAC layer in uplink, while some MAC-C are generated by G-Node B MAC layer in downlink. So reception of MAC-C, the UE receive MAC-C for SCell activation, deactivation from the network. The UE read SCell MAC control element and check bitmap to know which secondary carriers it should turn on or off. So in logs, you here is mentioned SCell index 3. So in 1 octet, here C3 is here. So it's pointing this SCell will be active. So these elements help the manage various control function like scheduling and power control and more. LCID is a logical channel identifier used to uniquely distinguish both logical channel and all type of MAC control elements. So LCID is transmitted and allowing for a variety of logical channel and MAC-C to be uniquely identified in each transmission. Here, here is 1 octet SCell activation and deactivation, and 1 octet. It's a 4 octet LCID is here, and MAC control element. So for 1 to 7, we using the 1 octet, and more than this, it's a 4 octet MAC-C. So in this SCell activation, deactivation, MAC control element for 4 octet, it's MAC control element 57 LCID and 1 octet for the 58 LCID. Each CI bit corresponds to configure SCell identify by SCell index I. So CII for the index here. So CI bit corresponds to a configured SCell identify by SCell index. So if CI field is set to 1, it indicates the associate SCell shall be activated. So if CI field is set to 0, it indicates that associate SCell shall be deactivated. CI field means C1, C2, C3, C4. I stand for index. Each bit in MAC-C payload directly control the activation state of its corresponding SCell. So in next slide, downlink MAC control element. Downlink MAC control element are short MAC layer control messages sent by G-Node B to control UE, timing DRX, bandwidth switching, SCell activation, beam management, CSI behavior. It's a downlink MAC control element used when G-Node B control UE behavior. Downlink MAC control element used when G-Node B control UE behavior. Number of bits in SCell activation MAC-C is equal to the number of configure SCell. MAC-C size adopts dynamically if SCell is less than or equal to 8 SCells. So it use 1 octet, and bits are packed left to right here in previous slide. So start from SCell bit mapping is start from here, first, second, third, like that. So 7 SL in one octet. And SL auto deactivation, it's a timer based. When activation is start, so SL deactivation timer is associated with the SL, and the network decide to active SL1 and SL3 suppose, so it send maxi field bit with the bit field 101, where C1 is activate, C2 is not activate, it's a deactivate, and C3 is a activate, like that. So dynamic SL activation improve spectral efficiency and power efficiency. It allow the network to adapt to traffic condition and enhance the throughput by aggregating multiple carrier, thereby improving overall system performance. So some additional points are here. Add SL based on measurement. Gnode VCU cell SL based on measurement report to the UE. So event A4 here. So neighbor becomes better than threshold. And UE shall be configured with only one SL at a given time. Here is if gNodeVCU is determined that CA is enable UE, so which does not have a configured SL, so satisfy condition to add SL, and it's sent to misconfig to UE via RRC configurations. It's a SL based measurement. Next slide is after activating SL. After activating SL, what is the flow of this after activation? So UE start monitoring PDCCH on the SL. If SL is activated, UE start monitoring PDCCH on that SL, and UE receive a DL data on the SL, and UE can transmit also UDL data if a UL CA supported, and SL deactivation timer also started. So it's a timing, it's a enumerated values here 40, 20, 80, 160. So when data is not received by SL, so it will be deactivated. Next topic added here for timing advanced group. It also important for CA. Here is the single tag and dual tag concept. Dual tag means you maintain two timing advance group in carrier aggregation. Each tag has separate timing advance and timing alignment timer, so allowing dependent UL timing alignment for different group of cells. That means in 5G NR carrier aggregation, timing advance group is configured by the RRC layer through MAC-CellGroupConfig message, and each configured secondary cell is assigned a specific tag ID. Means P cell have their separate tag ID and S cell have their separate tag ID in dual tag. So the G node B transmit a timing advance command via make control element. Okay, it's a downlink make control element which include the corresponding tag ID. Means tag ID 0 for P cell and 1 for SL. So upon the receiving TA command, UE update the timing advance value for indicated tag. Suppose that one tag ID is 0, so gnode maxi will assign according to tag value. So each tag operate with the independent time alignment timer. So allowing separate uplink timing control per group of cell. And in the normal carrier aggregation, we perform RH only on the P cell. SCell receive timing alignment through timing advance MAC-C if they belongs to different tag. Means SCell can be SCell have their own TA value, so it will be aligned. So dual tag means a separate timing advance control. So the timing advance MAC-C carries 6-bit timing advance command value, which is range is 0 to 63 along with tag ID. So the command represent timing timing corrections at the step that you apply to adjust uplink transmission. Means it's avoid the propagation delay. That's why it used for this. So each TS step, suppose that it one, so suppose that tag ID group ID 1 and it's give to 0.2 microsecond. It's a common numerology. For common numerology, a TS step is 0.25 microsecond. It will be uh, manage the delay. So so tag mechanism is always required for uplink timing alignment, and dual tag is only needed if carrier have different propagation delay, such as inter-site deployment. And next topic is F1 interface. Why F1 is come? So the F1 interface is a 3GPP defined interface between CU and DU. It carries control signaling via F1C and user data via FNU, enabling the functional split architecture and in 5G NR. So F1C manage UE context, RRC signaling transfer, cell configuration, CASL control, paging, mobility measurement configuration between G node B CU and G node B DU. So so this F1 in CA where it will be come in the picture. So when call setup means UE context is set up, and when the UE context modification is happen, so in this case UE context modification F1FE procedure is used by CU to update the existing UE context in DU for changes such as SL addition, so DRB configuration, BWP part update, mobility data reconfiguration. So all these things happen in UE context modification. And in CA perspective, SL addition when happens. So SL addition is an F1 AP UE context modification procedure where the CU configure a secondary cell in DU for carrier aggregation and DU activate the required radio resources. So that's all for the F1. Here is a reference. Thank you. Please like and share and subscribe.
Don't forget to subscribe.